Good evening to all. Welcome to Wallah. Are you able to hear me? And audio video, is it clear? Guys, let me know. सबको clear है क्या audio and video? Good evening to all. Yeah, hi. Kadir, Shinchan. Good evening. All right. Okay. इस सेशन में हम both theory of computation and compiler design दोनों हम यहाँ पर कवर करेंगे इसी सेशन में, राइट? TOC and compiler design. Okay. Yeah, Tails. Good evening. एक बार बताना यार ऑडियो एंड वीडियो क्लियर है क्या before going to the session, because we have 30 questions and it's very simple in right in TOC and compiler it takes less time to solve the questions. Shivam, good evening. Sritam, good evening. It's just like 30 questions 30 minutes you can always do in exam, but 1 or 2 questions may take 3 to 4 minutes. So you should know that the theory of computation and compiler design are the subjects where it takes very less time in the exam if you are prepared well. Okay. Yeah. Kajal, good evening. Tarun, good evening. Now it's total 30 questions only, but in case you need more questions you can always ask at the end. I'll just make it. Yeah, good evening SY. Right. चलो शुरू करते यार. आज की एजेंडा है TOC एंड कंपाइलर डिज़ाइन की मैक्सिमम रिवीजन होना चाहिए. ये सुपर 30 क्वेश्चन है वो एक्सपेक्टेड है, राइट? यहाँ पर 15 क्वेश्चंस देखेंगे और इसमें 15 क्वेश्चंस के साथ अगर कुछ भी आपको अदर कॉन्सेप्ट चाहिए तो डाउट्स पूछ सकते हैं. यू कैन आस्क द डाउट्स एनी टाइम, राइट? तो दैट इज एडवांटेज दैट इन लाइव सेशन यू कैन आस्क द डाउट्स इफ यू हैव एनी during this session. Okay, the first theory of computation, we're going to cover the most important concepts along with the doubts. Yeah, Tarun, you have, everybody knows, right? You have the Mahar revision on both TOC and compiler. Don't worry, you have the sessions, I think the next Saturday, not this Saturday, next to next Saturday, and the third Saturday from here you will have 2 sessions. Yeah, don't worry about the revision, you will be having it. Okay, the first question is the very famous question. Yeah, good evening Shari. Find the equivalent regular expression for the set of even number of ones in binary string. So you have binary string and you need to produce all the even number of ones in that means every string that has even number of ones you should produce from these expressions. You need to identify the equivalent ones. Can you do it? Yeah, quick. It is MSQ type, so you might have multiple answers. And one of the important type question, I'm saying it again, one of the important type question in the gate. Maybe they will ask for odd number of ones or even number of ones. It could be any expression, but one of the model type. You will be having the language and you have the multiple expressions to choose. Okay. You may use eliminate, or you may, if you already practiced, you can easily choose it. Okay, somebody says, Tamana says BD, whatever others, Chetan says BCD, and Sritam ABD. So this is where we struggle to choose the options, right? The actual answers are B, C, D. Why the option A? Here epsilon generates, but single zero is not generating. This zero is having even number of ones. That means 0 ones, having even ones. But you're not able to generate here single zero, right? So A is absolutely wrong option because it cannot be a right expression even though it generates even number of ones. Then what is the mistake? The option A is actually subset of our answer. It's not equal, but we want the equivalent. We don't want the subset, okay? Even though it is generating the even number of ones, it can't generate, this option A can't generate all strings, right? ये बहुत कम लोग को पता है यार, ये तो even number of ones को generate तो कर रहा है, but यहाँ पर here you cannot generate all strings which is having even number of ones. Yeah, no zeros you can't generate. So those people are answering option A. It looks like even number of ones, but it is generating only some of the even number of ones. But we want to generate the whole set of all even number of ones. Okay? Yeah, good evening, Raja. Everybody got this point? But why option B, C, D are equal? Why option B, C, D are equal? Have you remembered even number of ones concept? The multiple answers are correct, right? Even number of ones. So if you don't have the zeros, 2, 1 whole star. Is this correct? If you don't have zeros, this is the right answer. But here the sigma is equal 0, 1 as it's a binary string, right? So now the problem is any number of zeros can come any time, any place, right? But always you should have even number of ones. Now zeros may come here or may come here, may come here or may come here, right? These zeros and these zeros always same because you have these kinds of zeros here. So now you can write the simple expression by writing the 0 star everywhere. Before after ones and before after expression, like before after this Clinis star. Alright. So now you know how to write the equivalent answers. All these three are actually matches with this. There is no difference between these three. Okay. So when you simplify it, you will get all the three. Okay. Yes, please practice this question and this kind of questions too. Question number 2. Consider the following grammar for the language L. So you have something, which of the following string generated by the above CFG? So it's M, okay, MCQ. Fine. Which of the following string, if it is wrong, better to choose MSQ, because sometimes you may get multiple answers too. Which of the following string generated by above CFG? And let me write this, all of this. I don't want to choose MCQ here. Let me write some other string here. Double A, so otherwise triple A, triple B. Very simple one. Okay, please delete all of this and just choose properly. I want to be it is MSQ. Okay, let's see. How many of you know the language generated by this? One time it was a gate question. One time this kind of grammar, it was a model gate question. Oh, I have deleted all of this. Don't choose it down D. Think about the answers. Which of the following string generated? A, B, D, A, D, equal number of A's and B's. But that can happen any number of times. If you know the language is A power n, B power n, such that n greater than or equal to 0. This whole star, look at that, it is a star. That means this can be repeated any number of times. That means something like this: epsilon, AB, A square, B square, A power 3, B power 3, and so on, whole star. If you want to write like an expression, anyhow it's not regular expression, right? You can't write an expression because this cannot be represented with an expression. Okay, if you understand this, in the Clinis star, you can repeat any string any number of times. Okay. Let's see an issue. I don't know how many are there, but it's a super 30, right? So focusing on 30 completion first. Is that a power n, b power n square. When you do it, that double a double b and then double a double b. So when you do it, it's a power n, b power n power 1, a power n, b power n power 1. Remember, here n should be 2 and here n should be 2. These two no need to be same. Remember that too. The another one, same, double a double b, triple a triple b. So in the power 2 only, you can find in the power 1, put here n is equal to 2 and another one n is equal to 3. You will get the string. So I'm very sorry. A generating, B generating, and C. Oh, 1A, 3 B's, 3 A's, 2 B's. That is impossible, because you can generate equal number of A's and B's but not unequal number of A's and B's. Now triple A, triple B, just do one time. Yeah. Yeah, all right, gaming. Yeah, sure. Just whenever the question comes, just ask me, sir, tell me the shortcut and explain the closure properties. I'll help you. Okay, anyhow, the revision is there. Good. Thank you so much. So everybody got this answer? Yeah, C is wrong. If they ask which of the following string not generated, आप C choose कर लेना. String generated, you choose A, B, D. So this question I can make MCQ, MSQ according to requirement. Let's go to the question number 3. Yeah, true. Sure, Dev. I'll wait for that question, and whenever the grammar question comes, I'll repeat that. 3210. After this question 3, let's see any grammar question comes, then we'll discuss on types of grammars. Set of all regular languages is dash. So looks like you know this question, but answering is really important, right? It is, remember, MSQ. If it is MCQ, maybe your luck, you might have the luck, but here you need to understand. You don't have the luck to answer this question, right? You need to understand and answer it. Then only possible. So far you have answered A and D. A and D. Absolutely wrong it is. Okay, it is MSQ, right? A, D. Still you have the wrong answer. Do you know why? How many of you know these two are exactly same? RE but not recursive. Another name is undecidable but semi-decidable. These two are exactly same. If the B is the right answer, then C is also right answer here. You are answering, somebody saying D. What is D? Can you understand the difference between A star, B star? Is it regular language or set of regulars? It is regular here. It is regular language. The question is not about regular language. It is about set of regular languages. So this L is A star, B star. Now another L, you have the A star, a B star, A plus B whole star. This is another language in which you have the languages. What you have, this is L1, this is L2, this is L3, this is L4. Both are different, right? This is set of regulars. You don't have a DFA for this. Set of regular languages. But this is one regular, not set of regulars. For this, you can design a DFA, but for this, no DFA. Are you able to understand? The regular language will have a DFA, but this set of regulars, you don't have a DFA because it's a set which has every regular. Now DFA need to understand every regular. How? If one DFA can understand all regulars? No, right? One DFA can understand only one regular, right? So understand the difference between these two languages. Now we are asking the set of regulars. We are not asking one regular. Now you should never choose the D. This is completely wrong. One person, set of persons, both are different, okay? Everybody was choosing D, D. Why D? D, and you don't understand set of regulars and one regular, plural and singular word, you don't understand? Clear? So look at the sentence carefully. It's not one regular. I want set of all regular languages. This set I am asking here. This set is there. There is another set. There are two sets here. Set of all sets, right? This is a one set, regular set, set of all regular sets, okay? So have a clear understanding. D never be equal to the question, okay? You know this point. If I say this L1 and L2, definitely L1 not equal to L2, you should say that, okay? And never be equivalent also. Okay, now set of all regular languages. If you go to the previous one, if you go to the previous, this one, this is a set of all regulars over A comma B. So do you have a Turing machine for this? For this you have a DFA, for this DFA, you have a DFA. That means every input, every member, every string. Now this is a one string to the machine. This is a one member, one valid string, you can say that. Every string or every input, you can say every input or every member has a logic. Every member has the logic for, so I can build L2, we can build Turing machine. Why? Every member has the logic, that logic is the DFA. Or every member has a Turing machine, so that L2 can also have the Turing machine. You can say just logic exists for every valid member. So I can say it is recursively enumerable because we have a Turing machine for this problem. And RE but not recursive, why we say it? Because when you look at its complement, L2 complement will come as set of all non-regulars. See, every non-regular, can you design Turing machine or can you design a DFA? Any machine is fine. Logic is important. Every non-regular, do you have a Turing machine? No, right? Some non-regulars are not RELs. Here, not RELs also can come. So that's why L2 complement, you don't have a TM. Why? Because you cannot prove a logic for every non-regular, but you can prove a logic for every regular. That's why you have a TM, you don't have a TM. Because of this reason, RE but not recursive comes. When RE but not recursive, the another name of RE but not recursive only, undecidable but semi-decidable. Everybody? So look at how you need to understand this problem. This is one of the important question, and every year it is expected this kind of model. Okay, A, B, C. Got it? The one of the blunder mistake we do in hurry-burry, that set of regulars and one regular we don't understand. Okay, this is very simple logic. Every regular you have a logic, that's why you have a Turing machine. If you want to say this problem is decidable, every non-regular also you should have a logic. Semi-decidable, another name only, RE. This is RE, undecidable means not recursive. See that name there, not recursive. We are saying same, right? Not recursive and RE, just synonym. RE but not recursive but RE, both are same here. Everyone? There is no difference between these two. Not recursive, another name is not decidable, means undecidable. RE, another name is semi-decidable, right? There is no difference at all. You just make a synonym. You will definitely understand, both are actually the same. Everybody got the point? Not recursive means not decidable. Not decidable means undecidable. RE, another name is semi-decidable. Over. Okay? Yeah. Question 4. Yeah, please like the session. Also, don't forget to like the session, right? Yeah, what is the answer for the next one? I'm sorry, guys, not able to see the chart right now. Great. Come on. Okay, let me use another one. What is the answer for the next question? No answer set. Vikram, Kadir, Nishu. What are you doing? What is the answer? This question is very, very easy. Why? You are asking what is the fact, right? You are asking what is trivial. Answer is why. Do you know, by default every grammar is unrestricted. By default, if the given input is Turing machine, no need to check whether it is accepting RL. Why? No need to verify. No need to verify given TM. No need to verify given grammar. Why? If I ask very simple question, are you a person? Are you a person? Do I require an algorithm to check you? Blindly, I can say you are the person, right? So I'm giving you Turing machine. I'm asking, is this TM accepting RL? Will it ever accept not RL? Is there anything in any Turing machine that is accepting not RL, not RL? Never, right? Every TM, no need to verify TM here. Every TM in the world every TM accepts RL. Why are you verifying it? Why do you need a logic? Right? So set of this represent set of all TMs. This represent set of all blindly grammars, unrestricted grammars. Simply you say grammars here. That's it. Everything you give me, I'll put in my set. Why? Because this complements will be empty. If you do this complement of L, you will get empty. Complement of this L, you will get empty. You will never get anything else in that, right? So they are trivial questions, right? They are trivial questions. Both are actually decidable, right? In the world, every grammar is unrestricted. Every Turing machine is accepting RL. That's a fact. I no need to ask, right? I'm giving all black color pens. I'm asking, is it a black color? That's a trivial question, right? No need to verify it because I'm already saying I'm giving you black color pen. Can you check, is it black? Yeah, obviously you are giving me the black. So I'll say without verifying it is the black. That's it, right? These are the trivial questions. They are always decidable. Okay. So it is MCQ. I'm expecting only one to be selected. Okay, good. Question 5. Next one. You have 3 languages, right? This is also another kind of expected question. There are different languages. It need not be CFL, decidable, recursive, anywhere. They can ask anything. Now, this is a subtraction, okay? If you are not able to see, it's a minus. Okay, put here minus. Come on. So how is the preparation going on? Because we are almost near to the exam, right? If you have prepared well and you have completed the syllabus, only one thing, ensure that stop fearing and just do better as much as possible. Try to give the best effort in this last moment. B, D or A, B. Two kinds of answers are coming. B, D or A, B. Yeah, you will have fear, nobody can stop it, but you should try to avoid it. If you feel so stressed, then it will impact on your preparation in the last minute. You should scare when you are not aware of it, right? Suddenly it happens, you should scare. You know that the gate exam will be there, it will be 3 hours, and you know the impact and you know the difficulty level. Only the thing is what you can do, that you should do, right? Whether it goes well or not, be confident, because we do not know what happens in the exam, but give your best. Before giving and without attempting, don't fear. Anything might happen, right? You might be the first ranker, you might get 1000 rank, doesn't matter, but give your best. BD, answer is BD. Okay, let's focus on this. The first one, the L1 minus L2. What is L1? L1 is CFL and L2 is recursive. Recursive and decidable both are same, right? So recursive. CFL minus recursive. Can I say CFL minus recursive means CFL intersection recursive complement? Recursive complement is recursive, and CFL intersection recursive, is it always recursive or not? Recursive means decidable. So option A is definitely correct. Oh, we need to choose incorrect. So that is a one more problem. The question you should read properly. It's about incorrect. So this is the correct. So we need to choose incorrect statement. Everyone? So some people, that's why they are going to answer the correct ones. I can see many people are answered A because you are looking for correct, but the question is for incorrect. Next, L2 minus L3. Decidable, there's a recursive. Let me write recursive always. Recursive minus RE. So recursive minus RE, do you know what is going to happen? We don't know what's going to happen, because recursive intersection RE complement you will do. RE complement don't know what's going to happen. It may be not RE. Then if it is going to be not RE, we will not understand. So here what's going to be the problem? Problem is, if you are trying to understand that complement, you don't know what's happening here. So this result is anything, we don't know. So B, we can't say. Of course, you should not. Definitely this is, not guaranteed decidable. Another one, L1 minus L1. So easy, right? CFL minus CFL. It could be, CFL minus CFL. Oh, don't say empty. We are not taking the same language. Some CFL it is, okay? And here L1 is something like CFL intersection CFL complement. What is the CFL complement? We know it need not be CFL, but it's definitely recursive or definitely CSL, and this is going to be a CSL, so recursive, so decidable. This is correct, and obviously this is incorrect, this is correct. We'll choose answers later on, because cross checking is definitely different answers, right? And L3 minus L3, that is RE minus RE. Will you get decidability? Will you get decidable? RE intersection RE complement. Almost, if you observe, both are concluding same. It could happen anything. How can you say decidable? So this is also incorrect. Now look at the question, which one you need to choose, correct or incorrect? You need to choose incorrect. So B, D, R should be, yeah. Tamanna, intersection takes the bigger one. No. No. What is intersection takes bigger one? Who said intersection takes bigger one? Uh, till what language you, if it is intersection closed, you can't say that all. See, if anybody says intersection bigger, right? So DCFL intersection CFL, will you say DCFL? Will you say DCFL? Wrong. Will you say CFL? Wrong. How is intersection is bigger? It is CSL. Always. So this is a one important point. Don't look for the bigger. That might be the wrong. Even though many times it could be correct, many times, not here. Like DCFL intersection regular, bigger one is always right. Here it is fine. This is correct. And CFL intersection regular, bigger one is fine. And CFL intersection CSL, bigger one might be correct because it's closed for CSL. And CSL intersection recursive, always recursive, that's correct. And recursive intersection REL, then definitely REL. But this is not always correct, especially this case. Okay, one case it fails, there it is. In the intersection, for all of them, you can choose the the language from bigger class, the type of the language from bigger class. But here, this one will not going to satisfy the bigger class language. Okay, so especially this point. But remaining, yes, you might be correct, but keep that point. It's not always. Okay. If you want to make any shortcut like that, bigger one, just understand in which cases it won't work. Okay. Some cases it will work, some cases it won't work. Remember, maximum cases it is working, one case it is not working, you can remember it. Okay. Got it? The reason also we had, intersection was not closed for DCFL CFL. That's why in the next case here, the intersection for CFL DCFL, it was not closed. That's why we are not able to assume this is a CFL. But look at this here, CSL closed and closed in the intersection, right? So we can assume this is CSL intersection CSL, you can always get a CSL. So intersection closed for recursive REL CSL, that's why answer is coming a bigger one, bigger type. Okay. So do not conclude such things without understanding. Fine. So no doubt, right? You don't have any doubt here, right? Okay, let's move to the next one. The reducibility. Okay, the grammars I'll help you, in soon. Well, once you get the grammar type question. Yes, that is correct, right, Nishu? Always CSL, but may or may not be CFL. I'm not saying not CFL. Always CSL, but may or may not be CFL. Yeah. Please answer this question, and I'll also write this point. Even CFL intersection CFL, the same answers will come here. Okay, both answers are same. Okay, for both you need to apply the same concept. This is kind of transitivity property. The classical short, really I don't know what is CFL here. I need to study any textbook and come here. CFL, CSL, all the things you need to explain. Need 2-hour session for that. You need to sit. Just need to understand what is context-free language, right? You should come to the 2-hour session here. That I need to take another YouTube session. BD, everyone? So now you need to remember, after looking at these two reducibility properties, right? P less than, Q less than R. Everybody got this point? So now you just make the picture like R is here and the Q might be this much, that P might be this much. Okay, so we got this kind of relation. Now, when you look at this project module relation, right? So P is like a module to the Q and Q is like a module to the R. R might be a bigger project which involves Q and P inside. So now when the R is solved, that means both Q and P are solved. But if P is unsolved, then Q and R also cannot be solved. So this relation always exists. Okay, it is a transitive relation. So if R is decidable, then both Q and P will also be decidable because P and Q are actually depending on R. Okay. And now when P is undecidable, because P is used within Q and P is also used within R, then that will also be undecidable. Okay. So P, Q, R. So when you are talking about undecidable, the flow will be like this. Undecidable flow. When you are talking about decidability, the flow will be from right to left. That means if this is decidable, both will be decidable. But sometimes they may ask, only Q is decidable, then you can say P is decidable, but R we do not know. Suppose if they give, if Q is decidable, then P is answered, we can answer it is decidable, but R we don't know. So it depends on what is decidable here. Okay. Yeah, I'm studying 10th class, classical short. Please start, I'll come to your classes. Yeah. I don't know what you want to study from here. Do you know the channel name? Now you can easily choose, right? If P is undecidable, then both Q and R are undecidable. And if R is decidable, then both P and Q are decidable. So you choose B and D, and you need to choose the correct one, that too. Yeah, YouTube में please don't attend every live session, right? It's a whole world, right? यहाँ पे यार सब कुछ चलेगा, सब क्लास में नहीं जा सकते यार, because you have the free internet. Okay, question number 6. अब वो भी चार्ट कर रहा है, वीडियो भी नहीं देख रहा है यार, चार्ट कर रहा है सर, क्या करे यहाँ पर. और एक क्वेश्चन भी पूछ रहा है, CFL CSL क्या है. सब्जेक्ट बोल रहा है 12th है, टाइम पास कर रहा है क्लास में, वेस्ट करने के लिए आया क्या, कहाँ से आया. Good. Everybody done? Any doubts here? Clear? Okay, great. Chalo, 7th one. But remind me that grammar, somebody asked the doubt, right? Type of the grammars. At the end of the TOC, I don't discuss, please ask me again. L union A star B star, is it regular here? L is a CFL. Where is the old star, is it missing? L union A star B star, or what do you want? Is it all star? Yeah, tell me exactly what do you want. Both are different questions, right? If you miss the one star, the answer changes. If you're asking about this, the answer is always A plus B whole star. And if you're saying this is CFL, and I can assume this is a CFL, I can assume this is a regular, because I'm saying always CFL. Always CFL, no doubt. But may or may not be regular, that depends on what languages you take. May or may not be regular. But when you ask me the particular case, this case always regular, because one of the languages sigma star. This is the universal fact. The sigma star union any language is a sigma star. That means it is always regular. This is the universal fact. This regular you can assume CFL, you can assume in general may or may not be regular. But this case is a fixed. But CFL union regular, the actual answer is if it is just regular, may or may not be regular. But if you fix it, then I need to fix my answer also. The now answers will change. If this is sigma star, I need to say sigma star. Oh, this is always regular. You can answer it. You can always answer it. Sigma star union L is always regular. No need to say anything else. Okay. When the languages are fixed, the answers also will fix. Right. Generalized questions are different from the particular cases. Generalized questions will be satisfying every option that you take. But when you take the particular question, the sigma star, you fix the language. I am not saying regular now. Any regular is different, sigma star is different. Okay? Sigma star means fixed regular. But we were not answering for the fixed regular. Any regular, my answer will satisfy. That was a different question. Okay? This is completely different question. CFL union regular, always CFL. But we don't know. We don't know about regular. It may or may not. Because that may or may not happen. Now we will know because you fixed one of the regular. If you fix, for intersection, if you fix pi empty language, result will be always pi. Okay? Some other doubt. Okay, Nishu, your answer is something different. L union A star B star. Again, we don't know. Anything could happen. I can say if L is CFL, then the answer is CFL. That's all we can answer. We cannot conclude yes CFL because that's satisfying, right? Now we can easily answer it. You can see how I'm going to answer it. A star, B star. You can see A power n, B power 2n union A star, B star. I can see that the result is this one only. Okay, so this is already covered here, and anyhow this language is definitely not regular, so you can always say CFL may or may not be regular, may or may not be regular, sometimes regular. I can show you one example why you get always CFL. Okay, just I'm showing it. CSL Dev. Okay, another question is like you have A power n, B power n, C power n, D power n is a CSL, and hence it is recursive, and hence it is recursive. I'm not saying it is not recursive. It is CSL, hence it is recursion. It's a recursive language. It is recursive language, Dev. Everybody? I hope you understood my point, right? Okay, let's go to the other one. You know, that day I took 8 hours class, right? 8.5 hours. That day my throat बिल्कुल खराब हो गया था उस दिन. BD. Oh, great. So this is, you have a dependency, right? You have a dependency. That dependency you can't eliminate. So here also you have a dependency. But this one, it's just like 1 star, 0, 1 star. And when you look at this, 1 star, 0, double 1 whole star. So these two are regular languages, right? Very easy question. Did you see how much time it took? Is there any subject that can be solved within seconds? Just you tell me, if you have the clear concepts in TOC and compiler, right? When you read the data, you will get the answer. If I am wrong, just cross check the gate PYQs. How many gate questions you can solve within 1 hour? Maybe all the TOC questions, maybe all the compiler design questions. That never happens in any other subject. If you know the concepts, the most of the questions from TOC and compiler design can be answered in few seconds. That is the beauty of TOC and compiler. That means you can save a lot of time. Remember, if you don't know the question, just ignore it. Don't attempt it, you will not get the answer to. But when you read the data, right, you got the concept, then you will get the answer too. So remember this two things, from TOC and from compiler, you understood the data, that means you should get the answer. If you don't understand the data, better not to attempt. That only two things happens. Mostly you will never get confused with the data. Either you will not have the clarity, or you don't know how to attempt these two subjects. Okay, in whole gate, these are the two subjects which can be answered in few seconds if you have the concepts. Okay, because you don't need a pen and paper. Do you need a pen and paper for this? Right? You only know that how much time you are taking to answer it in few seconds. Okay. 8. But when you have some new data like this, then you should interpret. Interpretation is very important. Even this can be solved in seconds, but interpretation is very important. Yeah. Please read the data and interpret properly and answer in a minute. Like 10% of the TOC and compiler takes time, no doubt, but not 100%. Yeah, Nishu, I'm doing it, but still you can't stop the infection. Look at, really, do you need a pen and paper? Again, you don't need it. If you have studied these two subjects, right, just by looking at, you will get the conclusion. Six, 7, 5, 8. Why? See, first, how to find the number of equivalence classes. For this, how many states in DFA? You know that answer, don't construct. Number of states in DFA, how many? Of course, minimize DFA, that too. How many? Starting with AA. That requires, the minimum length is 2, so you require 3 states plus 1, 4 states. And here, the number of states in DFA who ends with AA, you don't need a dead state. So minimum string is AA, you require 3 states. So 4 is nothing but the number of equivalence classes for what? This L1. For L1, and number of equivalence classes for L2. Okay. Now 4 plus 3, just I asked 7, you need to answer. That's it. Nothing needed, right? You know how to construct them just in logically. Logically, you should understand how many states. No need to put pen and paper because you did many times this kind of questions. But if you don't know how to construct DFA for starting with AA, ending with AA, really we can't do it in the exam. No doubt about it, right? If you're struggling to understand number of states in starting with AA, ending with AA, then definitely you need to ignore this kind of question. Okay, I hope those people are coming to practice. You are aware of this number of states, right? If you really wanted to construct, now I can do it. Do you really need to construct these two DFAs? Anybody needed starting with AA, ending with AA? No, right? Okay. Next, another important concept, complement. The complement property should never ignore for the GATE exam. At least one question I see that it depends on the complement, either in expressions or in machines or in languages or theoretically somewhere. You should aware of all the complement properties. That means for all the domains, complement property should be remembered. I'll give that point too after this. Abhishek, what should I do, yaar? Should I bring the whole world to this session? No, right? We can't. Focus on the question. Answer, Abhishek. Is focusing on how many are live, yaar? AC? you need to identify the true. Complement of regular. Okay. Should I ask this question another way? Okay, I'll just ask another way. Remember one thing, the questions regular complement, so you need to identify the true, okay? You need to identify the true statements. There are two kinds of questions which confuses in the exam, so both of them I am writing here. So you need to understand which one is the right. REC means assume recursive, and that is also called as decidable, okay? RE complement, is it RE? So there is another question. Okay, regular complement, is it decidable? DEC means assume decidable, okay? DCFL complement, is it decidable? CFL complement, is it decidable? And CSL complement, is it decidable? Recursive complement, is it decidable? So these two kinds of questions you should aware, okay? Okay, let's see who will answer it. Is this true? Yes, tick when I put correct, correct, wrong, correct, correct, wrong. Okay, everybody knows why? Because that depends on the closure property. So complement closed for regular, so result will be regular, and not closed for CFL, that's why need not be CFL. You should not say equal to CFL, we don't know that, we don't know that, okay? And RE complement, we don't know whether it is RE or not, so we can't say always RE, sometimes only. So this one is very easy, true, true, false, true, true, false, okay? So you can say that true, true, false, true, and true, false, okay? Yes or no? This one, decidable, 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 right? Only this one you cannot. Why? Because regular complement is, you need to see this answer. Regular complement is regular, that regular you can call decidable. And DCFL complement is DCFL, so this DCFL you can call decidable. CFL complement need not be CFL, but it is context sensitive language, so that is also decidable. And what else? CSL complement is CSL, so decidable. So till here there is no issue with the decidable. This is true, all are true here. So only the confusion happens, these two statements. CFL complement is need not be CFL, it's not closed, but the result of CFL is always called as a recursive language. Result of the CFL is always called as recursive language, but complement is not closed for CFL. Two statements you need to remember, that is complement is not closed, that's true, not closed for CFLs, but complement of CFL is always CSL, so it is decidable. Decidable means what? Recursive. So these points are completely different, okay? These 2 points are completely different. One talking about closed or not closed, other talking about result of CFL, okay? Result of that complement of CFL. So no doubt, right? Because some people assume that closed and decidability, they assume the synonyms. Actually, they are completely different meaning. Okay, done? Okay, let's answer. Complement of regular is regular, complement of CFL need not be. Actual answer should be what? Need not be CFL. That is the right answer. Or you should say CSL. That is also right answer. Okay, recursive set complement is recursive and need not be RE. Abhishek, I cannot understand why are you coming here, yaar. You don't ask me one doubt here first, then I will teach you in English. क्या क्या करने के लिए आते यार लाइव में? डिस्टर्ब करने के लिए? अच्छा है, डिस्टर्ब कर सकते, बट मुझे नहीं यार, मैं डिस्टर्ब नहीं होऊंगा. आपका नाम बताओ, एक बार नंबर दे दो यार, अभी कॉल करता हूँ आपको। चलो गैस नेक्स्ट क्वेश्चन कर लो यार, हम कुछ नहीं कर सकते ऐसे वाले को। There are two types of red, one halts, another does not. Tamanna, we'll discuss that. What is RED? Oh, REL, oh my god, बताना चाहिए था। एक कैरेक्टर, एक वर्ड, एक सेंटेंस में अगर गलत दिख गया ना, पूरा सेंटेंस सेंटेंस मीनिंग चेंज होता है यार। टीओसी में यही दिक्कत है। एक सिंबल, एक वर्ड, एक सेंटेंस बहुत इंपॉर्टेंट है। कोई भी गलत है तो आंसर गलत हो जाएगा। ए बी MSQ, ओके। AC. Everybody saying AB, but they're saying AC. Okay, so mostly it looks like AB, then looks like, but let me check. Just now somebody asked, right, what is this L? Oh, L we know. This is a CSL, no doubt, but they did not ask about L, they asked about L complement. L complement is what? Everybody saying AB, 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 but actually A, B and C. And Dave, you have chosen C, right? When it is CFL, why don't you choose RE, right? CFL is the best answer for this. It's just similar to, I'll just tell you two things here. Remember these two things. Okay, let me write in on this slide. L1, everybody knows this is not, what is this? Not CFL, right? We know it is CSL. But if you do L1 complement, right, you will get a CFL. So what is that language going to be? Something like this. Okay, let me write that. A power M, B power N, C power K, such that somebody is not equal. We don't know who is that going to be, but somebody is going to be not equal. Okay, and then union, if it is not in this sequence, the sequence might be BA, that's before after A plus B plus C whole star. This sequence never comes in this ABC form, right? A is followed by B is followed by C, it interrupts. Either in this form, if not this, union, that BA, if it is not, either CA or CB. So CA union, or it could be CB. Of course, before after anything, that X means assume anything. X means assume A plus B plus C whole star. And this is, do I prove it is CFL? Because this one I can design a PDA, this one I can design PDA, PDA, PDA. 4 PDAs I can combine. Yes or no? सबको समझ में आया? राइट, अब देखो ये पूरा लैंग्वेज है, जस्ट वन लैंग्वेज, राइट? दिस इज वन लैंग्वेज. What is this have written? It is just one language. This is union of 4 forms. This is actually called as L1 complement. Just similarly, why can't you write A power n, B power n, C power n, D power n? Then you write here A power, B power, C power, D power, and any of these two might be not equal, and here might come like, you know, BA or CA, CB, even DA, DB, DC, all the unions you take here, and that's definitely going to be a CFL. Everybody, So similarly, you can form for the other four symbols too. एनी कमेंट विच इज नॉट रिलेटेड राइट, उसको इग्नोर कर लेना यार, हम कुछ नहीं कर सकते अभी राइट. डिस्टर्ब करने के लिए आता और मजा आता, बट इसको कॉन्सेप्ट चाहिए पहले, उसके ऊपर फोकस कर लो, चार्ट के ऊपर नहीं राइट. इज इट क्लियर? ए पावर एन, बी पावर एन, सी पावर एन कॉम्प्लीमेंट को कैसे आप बोल सकते इसको सी एफ एल. व्हाट इज दिस? ए कॉन्टेक्स्ट फ्री लैंग्वेज, बट इसको DCFL नहीं कह सकते. इसकी वजह से यही आंसर है, सिमिलर आंसर है इसके लिए भी. ओ कहा गया? Even this is not. Where is that question here? Did I miss this one? So now similarly L complement, what you can write? Something like this. Let me write the union completely, right? The L complement, I'm just writing here L complement is equal to, so you need to write all the unions here. What are they? One case A power M, B power N, C power K, D power L, such that M not equal to N, or M not equal to K, or M not equal to L, or N not equal to K, all choices, or N not equal to L, or K not equal to L. Really we don't know which one is going to be not equal. This is the one. Other one is going to be that BA before after anything, or what else, CA before after anything, or CB before after anything, and DA before after anything, that's DB before after anything, DC before after anything. So do union of all the forms, you will get a context free language, because every form you can write a CFL, you can design a PDA, and union of all these CFLs is again CFL, right? Done? Okay, next one. Question number 11. Yeah, thank you, Nayasha. If you are biggest fan, then please answer the questions too, right? Thank you for being fan. Yeah, nice Manjit. I'm sorry guys, nobody is there to block the comments if anything unrelated to the content. We are here to provide the content, right? See, concatenation. We have seen difference, complement, and now we are seeing the concatenation. The another important operation, concatenation. There is another one, intersection also. Everybody saying C, is that correct? Okay, let me see. It is MCQ? Oh, I thought it is MSQ. But always assume it is MSQ. Okay, always assume it is MSQ. You got one answer, you might be ignoring, right? So keep it as MSQ, so that you will try for every option. That makes more clear in choosing the options. C or D may be right. Oh, really? Okay. Okay, first one, concatenation, right? First we'll understand what is it. Is it CFL? No, right? It is not CFL, we know. As far as we know, right? It's it's a CSL. And this one is a reverse of the binary number that we know, DCFL. And this one is a CFL, but is not a DCFL, that you should know. Right, ये तो clear है ना सबके लिए? Now, what is happening when you do L1.L2? Remember that too. L1.L2, you should understand. Don't use the closure property to say answer is what. Okay. L1 is W hash W, right? The form you should write. Then you will understand. L1, L2 means you will get something like this. W hash W. And L2 you need to make. So I'm making here W1, W1. And then you get dot here. And other one, W2 hash W2 power R. So this is your language. W1, W2 are any binary strings. Now what is the problem here? The same W1 should come here, and whatever is left, that reverse should come here. But this part is, again we have an issue. So this is what? Not a CFL again. The problem with the first part itself. How do we verify this part? We don't have any logic. Right? Conclusion, we can't say anything because there is, it's not equal to A plus B whole star. Right? You can't say that way. And this one, L1, L2 here. Oh, same answer, right? Why we are going for this? Already we got not CFL, so we don't choose. We need to choose a correct. We don't choose it. Now L2, L3. What is L2 dot L3? L2 is something like W1 hash W1 power R dot. If you have any doubt here, please ask. You may ask, sir, why we are not writing all W's? Because two different languages. When you put together, right, you can't have the same variable to represent the strings. So you need to change the terminology. Here W1s, here W2s. Because when you concatenate, what happens if you write all the W's? You're trying to say W power R, W power R. That means you're talking about the same string, but actually we may not, no need to talk about the same strings here when you concatenate. Here any string, here any string, right? So that you should remember. Now this part, so first part, maybe you can do with the DPDA till here, but from here, this deduction cannot be done with the DPDA. So somehow you need to use the CFL, DPDA logic. So this is going to be CFL only. You can't say DCFL. The reason is this part we cannot cover with the DPDA. Okay. Yeah. So you can push and you can pop. Then again, we don't know this non-deterministically, you need to push and pop. So that can be done with the non-deterministic PDA. So L2, L3 is definitely CFL, but you cannot say it is DCFL because already it is not DCFL. Only C is the right answer. Everybody did it. Yeah, everybody did it. That's a good point. Because one of the famous model in the gate question is WW's form. That they may put hash or they may use a reverse or any kind of concept. यहाँ पे कोई डाउट है और एवरीथिंग इज क्लियर? ओके, आगे चलते हैं. Yeah, another interesting question here. The similar kind of data was asked multiple times, but every time they come up with a new question. The same way I come up with a new question today. Right? Earlier they came with the decidability or countability, this kind of questions. Now I come up with a Turing machine. Good. So where are you writing the gate exam for this year? I mean next month. What is your center location? Did you see your hall ticket? Did you receive the hall ticket, guys? Okay. Patna, Bengal, Muzaffarnagar. Including center number, so I can't come there. 25 kilometers, so lucky Manjit. Srinagar, Chennai. There is all the states are there almost, right? Ranchi. Right. Jamshedpur, Bihar, Vishal. So don't go for on the same day. If you are, it's a center is far away from your place, right? So 2 days advance you go there. At least better to go 2 days in advance so that you will adjust to the environment, and that will be the easy. If you do 1 day before, right? So maybe water issue or any weather issue that you need to face. Yeah, good. Just hint, advice to everyone. So distance makes matter because traveling makes you tired. So just before the exam on the same day, please try to minimize the traveling time, because you need to spend 3 hours at one place with lot of effort, right? So be aware that maximum just do 30 to 50 kilometers maximum. So if you are above the 50 kilometers away, then better not to do the journey on the same day. Okay, that makes impact in while you sit in the exam. It's okay if you are able to manage, that's fine. Chalo. Powai, Mumbai is good, near to IIT. So which of the following is not accepted by TM? Indirectly what we are saying? Not REL. So what is not REL here? That is, somebody is not REL, you need to identify it is MSQ type. Correct? Now set off all palindromes over binary, right? There's 2 symbols only there. So what is it? It is actually CFL. CFL means what? REL. But we need to find not REL. And set off all strings over sigma is equal to A comma B. It means sigma star. It means A plus B whole star. It is in fact regular. If it is regular, no doubt it is also REL. Set off all languages. Oh, set off all languages means what? How do you write it? Something like this. L such that L subset of sigma star. Sigma is here, A comma B, you know that, right? This is nothing but 2 power what? L. It's nothing but power set of L. Look at how many ways you can represent it. It is definitely not REL. Why not REL? Because there could be at least one language. Of course, there are many languages. Here, there are many languages which are not RELs. Right? We don't need to worry which language is not REL, because representation would be difficult. You can use, there are proofs in TOC like diagonalization language. You might aware proofs, right? So such languages can be used to prove there are languages which are not RELs. Okay, set of all non-regulars. Here you want to talk about all non-regulars. Right here, L such that L is non-regular. Means you are talking about all non-regulars. Here at least one language, of course not at least, there are many languages which are not RELs here. In both of them, we have the not RELs are hiding inside. That means you can't build a Turing machine for this set. This set I'm talking about. This set, we can't build a Turing machine, because inside there are not RELs are hiding inside in both of them. So C and D both are not accepted by TM. Okay. Of course, undecidable, but don't say undecidable, because some of the undecidables are also REL. That's why don't use the word undecidable. Undecidable, you don't understand, do you have a Turing machine or not? Because some languages are undecidable, but still you have Turing machine, right? So don't use the undecidable word. We know it is undecidable, but the language itself is not REL. Both are not RELs, okay? C and D both are not RELs. What is your answer, Nayash? C, D, that's correct exactly, right? That's what I am showing, right? C and D. In the exam, if they ask, yes, C is undecidable, D is undecidable because they are already not acceptable by Turing machine, right? Definitely they are undecidable, no doubt. So look at the question carefully. You have the complete answer about C and D. Okay? Done? Yeah. Next one. Have you seen where I am focusing on? The most of the question that I am focusing today is to revise the important things, and that should enlighten what is needed for the exam. Okay, where you require to focus. Most of the questions in the exam, regular expressions and undecidability. So these two areas you require to focus. These two areas. And of course grammars too. Very easy question, but they wanted to ask the numerical answer type, so they can make any question to the numerical answer type. 1 or 2. What is this language? What is this language? Length of W is greater than or equal to. Everybody remember that? Greater than or equal to 2. At least 2 length strings. How many states required in DFA? Oh, one blunder mistake is they should mention it is here in DFA. Okay, that is my mistake. Okay, while making the data that I forgot to include the machine name. Okay, DFA, NFA, both should be, one of them should be mentioned, otherwise data is incomplete. You can challenge, if this question comes in the exam, you can challenge, are you asking about DFA or NFA? Okay, if it is not mentioned, then there could be another possibility. Whether it is DFA or NFA, you will get the same answer, then no need to mention it. So now do you believe that at least you should mention in finite automata or in DFA, in NFA? Will you get the same answer? First let's cross check that, right? At least they should mention finite automata. Of course they should, if not mentioned, are you getting the same answer for all these three? Because the regular language, right, will find the number of states only in finite automata, right? No other machine, because they have the different logics. Now, is that clear? Are you getting the same answer? When you find the minimum finite automata, minimum DFA, minimum NFA, will you get the same answer? How many states you will get for this? Anybody? 3 states. In DFA, 3 states also in NFA. Do you believe that? Do you agree that 3 states only in both DFA and NFA here? For this problem at least. For this problem at least. How many final states are there? How many non-finals are there? At least, right? So 1 length and 2 length. Accepted? How many final are there? How many non-final? So X is final states. Here X is 1 and Y is 2 and X minus 1. That's you can do 1 minus 2 is minus 1, minus 1, apply the absolute value, that you will get 1. Right? So here this kind of issue may be there, but for this question no issue at all. But at least they will mention finite automata. That's enough. No need to mention DFA, no need to mention NFA, because for both of them you will have the same number of states. Undecidable means, who said we don't have a logic? We will have a logic sometimes, right? Shifu, you did not understand the definition first. What is undecidable? Should I explain that undecidable? No, not now. Please watch other videos here. We have the crash course, other videos, right? Undecidable, there are 2 types. If the language is undecidable, right? 2 types. We may have the Turing machine, or we may not have TM. Even though we may have a TM, but we will never have, but no HTM. What is the meaning of this? For valid strings, for valid strings, you will have a logic. See, you got a logic. And definitely we know invalid strings, no logic, because you are saying undecidable. That's why this is restricted. Okay, no logic. Here only valid we will talk about, invalid we should not. Valid will not have a logic. That's enough. Well, these definitions are already given in the class, right? So please just revise those videos. Why we say undecidable and what kind of properties you should understand for undecidability. So don't use just word undecidable, you will never understand. There are two types of languages. This language we say RE, but which is not recursive. This problems we say not RE. So both are actually undecidable. Even though we have a TM, we'll still say undecidable. Okay. Next question. 13 is over, right? 14. Yeah. RE but not recursive. That word is very important. Yeah, next question, guys. Yeah, very interesting, right? Finite, infinite. Very simple when they ask it. See the name, even though I have given you total 30 questions from TOC compiler, but you know how many concepts I have explained. If you look back, right, so already many concepts were covered, nearly more than 50 concepts were covered. If you look at, do you agree that I'm not just discussing the question, every doubt was taken in the class, and also discussed most important properties like complement for many languages. Okay. What is the right answer? AC or ABC? What is the right answer? Okay, let me discuss. You got the questions right clearly. So what is L1 minus L3? L1 minus L3. What is L1? Regular. What is L3? Finite. And what do you say? Regular minus finite. So I'm just trying to say what actually comes. Forget about the options, okay? What actually comes? Regular minus regular, you can assume, because every finite is a regular. But is it always finite? No guarantee, because this could be infinite or this could be finite. If this is infinite, right, infinite minus finite, still it is infinite. So what I'm assuming, regular minus this can be regular, right? So regular minus regular, you can always get a regular. So this is guaranteed to be regular. So L1 minus L3 is definitely a regular. A is the right answer. What about next one? L3 minus L1. So that is very interesting. L3 minus L1, don't write what is L1, not required. Finite minus any language. What do you get? Finite. What do you get? Finite. So I can conclude finite also. So this is also right answer. L1 intersection L2, regular. L1 intersection L2. So anybody answered C here? Oh, blunder, mistake completely. Regular language, intersection, very dangerous language, infinite. Infinite means what is it? Is it CFL? Is it DCFL? Is it regular? Is it what? Did I mention infinite? Which infinite it is? It could be any infinite, right? We don't know what's going to happen. We don't know. You look at some examples. Regular, intersection, infinite. Why I'm saying we don't know? Look at regular, let's say, examples I'm taking to help you. Okay. Let's say A plus B whole star. Intersection, A power n, B power n. What did you get? Non-regular. A plus B whole star. intersection. I can take the A star. What I got? A star. Oh, this is regular. Did you see? Either you may get regular or non-regular. Even it can be not CFL, it can be anything. So you should understand clearly what is given to you, infinite set, but not a particular infinite. It should satisfy whole world. That's why the answer should be need not be regular. Sometimes regular, sometimes not regular. Okay. So this statement completely wrong. So when MSQ is there, have you understood कहाँ पे आप mistake कर सकते? You know, you almost did correctly, but because of one option, right, you might lose the whole one. Even you have given good answers, right, A and B, but because of this, you don't get the marks at all. Okay? Everybody clear this point? You had good effort, but the one C could, change your marks. Now, union of all this, it's, oh, I'm very sorry, this is actually infinite. There's something happened here, typing mistake, okay? It is INF, infinite, okay? Sorry, I'm very sorry. So this is, nobody was intimated, it's fine. L1 union L2 union L3 is infinite set. Is it correct? Then now D is true. Okay, D is true. Because one of the languages, right, the infinite union anything, that L1 union infinite union L3 is always infinite. Yes, that's true. Is there any possibility of the answer? Can I say, okay, let me try. If in the exam same question comes, let's say regular, intersection, infinite set, what can you guarantee? Anything guaranteed? Always. Is there any meaning of always? Can you say always CFL, always CSL, always recursive, always RE? We can't say anything. Is the actual answer will be need not be even REL, need not be recursive, need not be CSL, CFL, regular. Even what else? Need not be finite also. Even finite also, sometimes could be finite, sometimes could be infinite. See, anybody could be possible. Because infinite, which infinite? Is it REL or not REL? If it is really REL, right? If this infinite is known as REL, then regular intersection REL will be REL. But this infinite is not mentioned as REL, so we do not know what's going to happen here. If this infinite is REL, then definitely always REL. Because of this infinite, we have confused what language is going to be the answer. Okay? Need to read clearly what exactly. So it's unknown infinite completely. Okay. The last question in TOC, but I'll come to the doubts just in TOC. What else you need in this TOC? I'll just describe. But anyhow, you have the revision class too. Okay, any doubt you have, you can catch me in the revision. The next Saturday, we have the complete TOC revision. The question looks very, very big, but answer looks very, very simple. Remember that too. Yes, guys. Perfect. Got it, right? So whenever you see like a plus b whole star, 0, none of this, just focus on, can I answer that option without using pen and paper? Could be possible, right? If you have the 65 questions in the gate, there could be possible that 2 to 4 questions or 5 questions, around 5 questions, you can conclude that option, but don't know which are. Yeah, both are equivalent. One thing is true. But in this, the conclusion, so here the one option, both are what? 0 plus 1 whole star. That means every string is possible. In that, one option is enough to discuss, right? R1 is 0 plus 1 whole star. Here you have lot of options in R2, like epsilon, 0, 1, 00, everything we have. Just consider this answer is over. Here only you are getting everything 0 plus 1 whole star. And union you do anything, right? Remaining you don't need to work on. So just you do one thing. What is it? Just do 0 plus 1 whole star slash epsilon and union 0 plus 1 whole star, what else? 0 and comma everything, that union everything, the result is going to be 0 plus 1 whole star. So this conclusion is enough. Or don't assume it is same is wrong option. Suppose a by a you don't get it, you get epsilon. What you get epsilon, so L by L, it's a very difficult. What is answer? Are you getting my point? So remember this point, L by L, don't say epsilon. This is one of the important concept you have. Both are same. L by L, don't say epsilon. So one of the important point in the future exam, you may get this option. You may get this kind of question like L by L, don't say epsilon, wrong. Why? A by A is epsilon, correct. B by B, epsilon, correct. But L by L means L could be any language. That set we are doing, set by set, could be any set. So you need to be very careful. Don't say epsilon. So need not be equal to epsilon. Need not be epsilon. Okay. So remember that. You get beyond epsilon also sometimes. Okay. But you will get epsilon union. Epsilon may be there, but you will be having remaining some other things. Okay. Set by set you will get epsilon as well as some other strings too. So be careful this point. Don't say L by L is epsilon. This is false because you will get actually beyond epsilon sometimes. Okay. Just focus on, is it a string or language? Both are different. Okay, you got this point, right? So now we'll go to the doubts. Okay, before starting the compiler design, so you had some questions, right? Okay, somebody is asking, sir, can you explain what grammars are? Okay, I just need to do something here. Okay, I'll just put four classes. Okay, I'll write few examples to understand, but I may not give all the definitions here. See, if you have something like S derives S A or B, is it regular? Of course, in fact LLG, but sometimes it could be RLG also. Sometimes it could be RLG also. This is one type. Another type, let's say S derives AS or BS or CDE. This is what? RLG. Still it is regular. Everybody understood regular grammar. So this kind of grammars are what? Regular grammars. Right? Either LLG or RLG. Some grammars, different. Some grammars could satisfy both, but this is very special. And in context-free grammar, this is about regular grammar. RG, let's say RG. Let's go for context-free grammar. What is context-free grammar? That's LHS. You have exactly one variable. Right side is any. There is no need to look at. Only look at LHS. Like S derives AS, S, B, or A, B. Anything. Doesn't matter what is there. Just left hand side exactly one non-terminal. Okay. But this is not regular grammar at all. Regular grammar, these regular grammars are context-free grammars, but context-free grammar, no need to be regular grammar, right? This is a context-free, but not a regular grammar. But every regular grammar is a context-free grammar. Okay, this relation should be there. No algorithm issue, right? We don't have an algorithm, so we have only logic for the ambiguity. So, how to check? Given CFG is ambiguous. Okay, let me conclude that too. We can, or we have a logic. We have a logic for ambiguous only. We don't have a logic for unambiguous, but we have the definitions for both. Remember that too. In general, if the grammar is ambiguous, what is that concept? Why we have a logic for ambiguous? Ambiguous CFG will have a logic. There exists a string that has number of parsers greater than 1. So very simple. Only you need to find which string it is. How you verify it? You will start with 0 length, you will start with 1 length, you will start with 2 length. If definitely somebody is there, you will stop the logic. So that's definitely the logic. You know how to stop it. That means the grammar is ambiguous. Let's say how to check the grammar is ambiguous. Let's say S means the first statement, no means this one, unambiguous. S means ambiguous, no means unambiguous. Right? S as a logic. But if you want to say unambiguous CFG, no logic. Is a logic, right? This is a logic. Also you can use as a logic and definition. Now for all W that generated by the CFG should have exactly one parse. What logic? How do you all tell me? Parse tree. At least we will halt, right? This one we can halt. We can halt after finding the string. We'll go lexicographical order one by one, like maybe 1000 length, maybe 1 lakh length, doesn't matter. We'll just check 0 length, 1 length, 2 length. Once you got the string, we'll stop. But if the grammar is unambiguous, when will you halt? Every string you have to prove exactly parse tree. If this grammar is generating infinite strings, when will you stop? We don't know how to stop this. We don't know how to stop the logic, how to halt. Because I need to verify every string. Every string means how many strings are there. It could be possible the grammar generating infinite strings. We don't have a logic. No logic at all. Definitions are there, but logics are not there. Logic means can you halt or not. For ambiguous, if I give you ambiguous, you can come up with the proof why it is ambiguous. If I give you unambiguous, you don't have the proof, because how will you verify every string has one parse tree? Are you going to generate a one parse tree for infinite strings? Can you stop that infinite strings? Impossible, right? So this is the issue with the context-free grammar. That's why this problem, ambiguity checking, and there are two kinds of questions comes. Question 1, whether, two questions, let me write separately, whether given CFG is ambiguous. The other question, okay, of course question mark not required, for a problem it is. Another problem, whether given CFG is unambiguous. So these are the two different problems, right? Maybe look similar, but two different problems. Why two different problems? Because everybody will have the two things, yes and no. Yes, no. Who will be having a logic, who will not be having a logic, that will decide the answer. Here S will have the logic exists here. Here logic not exist. So using this concept, we say this problem we know undecidable, but not just undecidable, it is also logic. S has a logic, so it is RE but not recursive. That's a clear cut, because S is only having the logic. Here when you look at S, S means unambiguous, no means ambiguous, not unambiguous means ambiguous. So we will have a logic. S is no logic at all. When you don't have a logic, don't look for the what is no, because this is straight away, even though it is undecidable, but it is, S is not having a logic, so it is not RE problem, not RE problem. Is that clear? That's a shortcut, not for all the time. Yes, that's a major, that's a shortcut. Okay, regular grammar, yes, we have algorithms to check, but context-free grammar only we don't. Because regular grammar, why you have that logic? Because right hand side, any production you take, you will have just one non-terminal. You never have a confusion. Okay. But in context-free grammar, right side has no restriction. We don't know how the ambiguity comes. But in regular grammar, it is pretty easy to identify. Somebody can come up with their own algorithms too. So where are we? Okay, this is about CFG. What about context-sensitive grammar? Of course, the whole definition could be very difficult, but let's just understand a simple way. LHS derives RHS, and rules are not there. But of course, there is a rule that at least one non-terminal should be there. That's a common rule. And here the length of the LHS should be less than or equal length of the RHS. So this is the main rule. But there is no such rule. The LHS is exactly one non-terminal. There is no such rule. Now here, what kind of grammar it is? Something like this. S derives, let's say, AA, BB, something like this I'm writing. Suppose I want to do something AA, BC, or let me write AB to B, 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 or let me write a BB to anything I can write. I don't have any issue with this. Okay. So such a kind of production. So look at LHS and RHS length. 1, 4, 1, 1, 2, 2, and 2, 3, 2, 3. So when you look at these, every RHS and LHS length, the every production, this rule is satisfied. Okay. Chanchal, we can have epsilon, but that is a special. There are conditions like you should study the many textbooks to understand. If you have the null production, that non-terminal, better not to write the RHS side because it can decrease the RHS length. So you may have a null productions, but under special situations. Like every context-free grammar you can call context-sensitive grammar, right? So here null productions are there. Okay. So be careful, null productions are present. But when the null productions are present, then there are other conditions are going to come. Okay. So don't say epsilon will never come. No, that's a special production allowed. Okay, a very simple definition I'm giving, but I'm saying that, you know, there are many things to learn. It is anyhow not in the part of the syllabus, right? Just learn this point. UG means unrestricted grammar. Oh, no rule at all. LHS derives RHS. That means anything, here anything, no restriction. Okay. But books have different definitions. You know, as per the books, you can follow the definitions, no restriction at all. Okay, now the problem is, you know, if I write something like this, S derives AA, B, and AA derives B. If I do that, this is not a context sensitive grammar, but it is unrestricted grammar. So all these grammars are unrestricted. These two grammars are always context sensitive, and these grammars are always context free. But this grammar, context sensitive grammar, need not be CFG. UG need not be CFG. So when you are talking in this direction, or need not be, but when you are talking about in this direction, this regular grammar always CFG, regular grammar always context sensitive, regular grammar always unrestricted. So this kind of relation exists between the grammars. Okay, so which direction you are talking about? It's not the languages. Languages are different. These are the grammars. Okay, these are different models. Do not call them as languages. Remember that they are grammars. Everybody, regular language is different. Regular context-free language is different. Regular language is there, right? You can write RG, CFG, CSG, UG. Even look at this. What is the language? Can you see that? If anybody not aware of this, what is the language you get? Oh, just carefully look at A, what you get B. So language is just finite. Did you see that? It is a finite language. It is in fact regular language, but this is not a regular grammar, right? This is not a regular grammar, but still it is generating regular language. So remember that point. Okay, regular language, you always have a regular grammar, but you can also write unrestricted grammar. This is the best example. Regular language is generated, but this is not regular grammar. Okay, that statement you remember. For the exam point of view, यहाँ पर एक exam की question possible है, like regular language. Do you require always regular grammar? No need. You can also have unrestricted grammar. Okay, but regular language you can always write, but you no need to have only regular language, regular grammar. You can write regular grammar, you can write context-free grammar, you can write context-sensitive, you can write unrestricted grammar. Okay? A regular language can be generated by any of these grammars. Even non-regular grammar can generate a regular language. Is that statement clear? Non-regular grammar. It's a non-regular, right? Grammar is not regular. So non-regular grammar can generate a regular language. Remember that line. Okay? Non-context-free grammar. Oh, what should I say? Yes. Non-context-free grammar can generate context-free language. Non-context sensitive grammar can generate context sensitive language. These statements are always there. Okay? Okay, with this, I think you have completed, right? Any other doubts before going to the compiler? Can we move to the compiler? We have definitely revision class. There you can come up with a lot of doubts. I'll clear. Okay, let's begin with the compiler. First question. Yeah, the last topic I did the first question, runtime environment. Which of the following is true at runtime for the C code? You have converted C code into machine code, you're running it. So what could be the true statement? Maybe Nishu, not sure. That's a very rare question, but happened recent years. You should revise. In the revision, I will help you, right? Only one model question is there, one or two models. For that, you can take care. Just anything is possible. It's a very small topic, not covered. More and milli motion. Few concepts are, very rare. What is answer? BC? Need to understand the statement properly. What is function? What is function call? What is activation record? What is the return? And what is only one activation record? Every word is important here. Every function has only one activation record? Completely wrong statement. If it is a recursive call, that function will have multiple activation records. At different times, you will have different activation record, also called as a frame. Okay? Everybody? Because same function can have multiple activation records. Depends on how many times you call, what sequence you call. If it is a recursive call, definitely at the same instance you will see multiple activation records. That first statement, why it is wrong? The only one is failing. Okay? Every function will have activation record when you call it, but don't say only one. It could be multiple activation records. Every function may have any number of activation records. That's absolutely correct statement, because we don't know how many times you call, when will you call. If you don't call, 0 activation records. If you call once, you will have 1. If you call in recursive manner, you will be seeing more than 1 activation record too. Recursion is very important word. Why we are talking about number of activation records. The recursion who understands, they will get to know the activation records. If you are calling the recursive function call, right? Suppose main, you call another main. That means how this is going to happen? One, the main is called, again you called main, it's keep on calling, right? You see that the one function only, but multiple activation records. It's keep on calling. Of course, this is infinitely you are calling it. So operating system may or may not support. Of course may not support because the stack is the limited size during runtime. So after some time the stack will be full, overflow will happen. So segmentation fault or stack overflow will happen. Fine. So here you can see every function has only one is wrong because main has many activation records. Now every function may have any number of, yes, that's true. How do you call them? That sequence will decide. Every function call creates one instance. See that when you call first time, the one time is created. When you call the second time, you got another one. When you come again, the third time, you will get another one. So this one keep on creating. Every time you call, one record will be created. Of course that record will be pushed onto the stack. In stack manner they will be created. So every function call definitely creates one instance of activation record. You call 100 times in recursive manner, there will be 100 activation records will be created in a sequence, will be put on stack. Right? Every function return will destroy, will delete that record from the stack, but you are saying creates one instance. That's wrong. It will actually deletes. In here it says every function return will pop one activation record or will delete one activation record. That will be right. Okay, but here because of your writing create word, that's why it is wrong. Actually deletes. Okay, so if I write delete here, even this statement is also going to be correct. Everyone, so here B and C. Right, understood every statement, right? Let's go to the next one. I think this is a very famous question. You should do it very quickly. Okay, let's see how many of you can do correctly. Very famous question, compiler. First computation, follow computation. That's compulsory needed. If you don't have the time for studying compiler design, right, at least learn computing first and follow. You will be lucky sometimes. I saw one time the 3 marks were only first and follow. Yeah, everybody saying D. I think D is the right answer. What is first of F only, right? So just focus on here. 3 productions only there. In that 3 productions, epsilon already there. So everywhere epsilon, no need to worry about epsilon. Here E is there. So definitely E should be there. Everywhere E is there. So if you look at E and epsilon, you are not lucky because E and epsilon, there is no help. So only from this you will get an help. So here G. What is G? There are 2 options you will be having. G, either you can get this one or this one. So when you write first of GH, right? So you have 2 options. G might be GC or might be epsilon. When you put GC, it will become first of GCH union. Another one, epsilon, when you put here, you will get first of H. And here G again coming. So again you will be having 2 options. Again, why do you want to go? Let's put epsilon here. So you will get here C, you will get from here, you will get from here H. But already you know E and epsilon there. So E and epsilon already you have computed directly from this 2, right? This 2. Just do the union E epsilon CH. So that will be D answer. Okay, do systematically, don't leave any production at all. All the F production should be calculated. Right, this is calculated from EF, this is calculated from epsilon. There are 2 different productions. And third, this middle production, we have the lot of possibilities. Only the problem happens if you see epsilon. If you don't have epsilon, right, the answer will be pretty easy. Okay, remember that? Only when there is epsilon in the grammar, be cautious. The reason is because of this epsilons, right, you will get the C sometimes, H sometimes, because here you may put epsilon, here you may put epsilon. That makes that you will go to the next terminal. So when you have the epsilons, Just be careful in the exam, otherwise you are so easy. It will be so easy. Always remember, it will be so easy if you don't have epsilon for first and follow both. Okay, next one. Yeah, another interesting question. This is what? Numerical answer type. Remember that you need to enter the number that is produced for this input. Okay, that numerical number is going to come from this output. Let's say anybody can design it and print it. Oh, I'll make the tree. Meanwhile, you just practice it. Yeah, that's a good idea. Got it, right? So now we have the prints, right? So prints, I'm just adding them, one here and two here. There is another one, another one, another one, another one. So what you have to do, very simple, just pull all down. Very simple technique I'm giving. Just left to right you have to go and pull down one by one. So let me write that expression here. What is that? Print A to A, you need to print here 3. Here you need to print A derives A, 3 you need to print. And here there is D to C, print 6. Here B minus D is a print 4. And this one A star B, that's a print 2. And this one is A plus E, that's a print 1. So pull all down. How do you pull? Just this will be the first. And this will be the second. And just go left right, this will be the third, and this will be the fourth, and this will be the fifth. If you have only prints, right, the question will be very easy and nothing is given, just follow from left to right. If they mention something else, if they are not all at the end, if they are mentioning bottom up parser, and be careful, reverse of RMD you should do. Okay, when all are at the end and they don't mention, or they mention it L attributed or bottom up parser, just you can use this definition. So what is the first output? You can see the output, that is 3 here, and then 3, then 6, 4, 2, 1. What is that? Double 3, 6, 4, 2, 1. Everybody got the same answer? Double 3, 6, 4, 2, 1. Even that is a very big number, but it's so easy. Yeah. Even top to bottom, left to right, no need to mention. Just all the translations, just evaluate from left to right. Just pull down all of them without crossing any edge. So this should be this place. If you compare 1, 2, 3, 4, 5, 6, right, the order is this is the left to right order. Okay. So this 2 will never come here, because to come here, right, you need to cross. It's impossible to come here without crossing anybody. Oh, don't pull like this. Okay. So understand, simply go left to right, because you can save a lot of time rather than interpreting many other variations. Okay, going from top to down and then left to right in order takes much time. Okay, these kind of questions are there in the gate, and when that comes, you just follow this technique, will always give you right answer. Okay. 19. Oh, this is a L attributed. This is a L attributed. But when it's prints, you have very simple job, just execute them left to right. But if they are having any attributes, then this action will tell you do something and put somewhere something in the root. So that takes time, right? If this is there, it says that you do something here. This says that, let's say this one, Which one? Which one? This one. If you want to execute this one, you need to take this value and this value and do something with that and put here. So even though order is same, you need to send the values to their roots. So that takes a little bit time. But there are prints, you need to take the action immediately, so you can just look down what is there. Okay. Only when you have the attributes, so you need to do some things in the tree itself. But you can do the same way. Bottom-up parsing is different technique, right? If you really want to do the bottom-up parsing in the exam, always you do this, you will get the right answer, because I did not see any question which is other than this pattern. So far, in last 30 years, the only one model which was discussed, this model. In case if you had any confusion, you don't want to do this, you're not confident, then do exactly what they say. If the print is between production, and if the mention, and that's what I'm saying, if they mention exactly some technique like LMD or reverse of LMD or RMD, reverse of RMD, or L attributed or reverse of L attributed, just follow them exactly. Okay. But if they mention nothing, or if they mention L attributed, then always follow this. Always follow this. Okay. Even though they mention bottom-up parsing here, the answer will come same even though technique is not same. Remember my words. Even though you want to answer using bottom-up parsing, the answer will come same. That's what I'm saying it. You can always follow this technique even though they ask bottom-up parsing. Did I mention any bottom-up parsing here? No. Even I mentioned, you follow the same technique, because bottom-up parsing will take some time. You really want to do the bottom-up parsing, then you need to find RMD order, then reverse of RMD. In that, this will be the first one, this will be the second one, third, fourth, fifth, sixth. In reverse are RMD order 1, 2, 3, 4, 5, 6. This is the RMD order. So that numbering will take time. Everybody? But answer will be same. Only technique will be different. If you really wanted to do bottom-up parsing, it takes a little bit more time. Okay? But I'm saving your time for the exam, right? Why are you wasting unnecessarily going for bottom-up parsing? Answer will be same, na? If not same, then you should worry. Okay, next one. Consider the following grammar G. Yeah. Is MSQ. Careful, it's MSQ. Yeah, Nishu, you should put in a proper place only. You should pull down using proper place only. Wherever it is there, pull down from there only. Don't keep at the end. Yeah. 4 things you need to do. We know we don't have algorithm to check unambiguous, but still you should do it. A and C. Why is that? Sanket. B, C, D. Really? Chanchal is absolutely right. Okay. What is the shortcut for this question? Sometimes shortcuts work, sometimes will not work. Remember that? Sometimes, who is that? RR conflict, Sanket? Where is RR conflict here? Why do you get RR conflict here? Do you have RR conflict anywhere? I don't see any conflict here. Okay, let me give you some shortcuts. First, how do you check LL1? LL1, how do you check? The first A productions, let me do the concept for everything. A productions, we have 2 things, right? What you do? Check the first of here. Check the first here. First of A. Intersection first of BB. Do you have any conflict? First of B, it gives what? If, while, and D gives C. Nothing common, right? This is always pi. So no problem. So it is in LL1. In LL1. No issue with the LL1. So next, B productions. You have if something, here while something, and you have a D. But D gives either C or D. Anything common? If while or while C or while D, anything common? So here also it is in LL1. You know the shortcut, right? First of this one, if while you get, but it's different terminals, and you do any two productions, you will get different. So if while, if D, while D, nothing is common. So last one, D is straightforward. First of C, first of D, though there is nothing common in LL1. After checking all the pairs, you got the conclusion, okay, it is LL1. It is LL1. But do you know the shortcuts? That every LL1, remember these points, every LL1 is LR1. No need to check ever. I did not ask about LR0. I did not ask about SLR. I did not ask about LELR. I asked only about LR. Every LL is LR. Do you know that point? Every LL1 is LR1. If you look at LL1 grammars, right? If you look at LL1 grammars, right? All LL1 CFGs are actually inside that all, what is that? LR1. LR1 CFGs. So these two classes are having the subset relation. The class of LL1 grammars is a subset of class of LR1 grammars. You know this point, right? Everybody know this point, right? This will also holds for LL0, LR0. This any particular case, these two will work. If the grammar is LL1, it is always LR1. So no need to check ever. No need to check ever. So blindly you assume that it is always LR1. And also, if it is LL1, it is also always unambiguous. Do you know that fact? Do you know that fact? If it is LL1, LR1, and even every LR1 is definitely inside unambiguous only. But you cannot guarantee this is unambiguous, but not LR1. But whenever it is LL1, it's going to satisfy LR1, it is also going to satisfy unambiguous. But there is one interesting fact, that is, do you see any null production here? Do you see any null production here? Anyhow, let me write this. Every LL1 is unambiguous. Okay? Do you see any null production? Do you see any null production here? No null production, right? No null production, right? When you don't see any null production, please don't check any don't draw any diagram LR0, not required. Every LL1, remember this point. But if you have null production, we don't know what to do. Draw the diagram better. Every LL1 without null rules, without null productions, is always SLR1. You can remember this point. This is another shortcut. You no need to check even SLR1 because I don't have any null production. So this LL1 definitely SLR1 whether I check it or not. But when you have epsilon, you have to check it because we cannot guarantee if you have epsilon, may or may not. So this is another point. That means whoever knows all these points, right, they only check LL1, they just take it all. Right? It just happens within a minute. But those people who don't know these relations, they will try to construct LR0 diagram, they check SLR1 conflicts. Oh, it takes much time. Okay? Sometimes this kind of shortcuts will help you in the exam in MSQ theoretical points. Is it just solved with the theory only, other three options. Got it? First check, The LL1, all of them has a relation with the LL1. That's why they might be asked MSQ. Done? Let's go to the next one. Yeah, can you do the 20? So another model gate question. Yeah, please answer it. I'm just checking the chart. X plus Y. Yeah, I'm very sorry. Very good point. So that was my mistake while making. X plus Y. Perfectly all right. X plus Y only. Thank you. Just try, please. Okay. Any answers? 15, 15, 15. Okay, let me check. Yeah, this question you don't have any issue. I think other question comes, the similar one, but there you will see definitely an issue. Got the X plus Y value? What is the DAG? You need to construct the DAG, right? So how do you construct the DAG? So just keep something like this. BC, right? Okay, this time ABC will work, but that's fine. BC, you need to do subtraction. Okay, we will do that. So how many times you want to use? Okay, here you need to multiply, here also you need to multiply. So one time multiplication is fine, right? So multiply with A. A is here, let's say multiply. The same answer will be available in both the places. So now you need to do the addition. A plus the same A, right? So A plus with this result. So we keep here, okay? A plus with this result. And then the whole result is here, and with another plus, and left side is here, and the right side is the same result what you have here that you take. And how many nodes? And adjust this also node, this also node, this also node. So 1, 2, 3, 4, 5, 6, 7. 7 nodes. How many edges? 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. So just you need to do X plus 5 is a 15. Right, I think you got the answer for everyone, right? Great. Yeah, here not just B minus C multiply with A is the redundant. Okay, not just B minus C. The whole thing is redundant because this A star B minus C star A, actually they are commutative property. They'll give the same result. So remember here, this portion is used for twice. One is here, other is here. Okay. So another, sorry, I'm very sorry. There could be another kind of question will come in the exam. What kind of reductions you can apply? Code optimizations, you know, right? The one code optimization is called as common subexpression elimination. What is it? Common subexpression elimination. So this is a one kind of code optimization can be applied here. To apply this, you need the directed acyclic graph help. So this optimization in the exam, another question, they will give you code and they will ask what other optimizations are possible. So this optimization you should remember to answer it. Okay. Yeah, marathon is, revision of whole subject, right? So without marathon only, I'm trying to help, every question, whatever the connection possibility is there, I'm trying to help. But when it comes to marathon, we'll go in a sequence, topic by topic, do the revision and shortcuts, and many things we'll do. Okay, question number 21. Ankit Dole sir here. 11 is over, right? Shifu. B. Need to understand. Let's see, anybody can answer this question. Okay, I'm just putting 3 star because I see that wrong answers. I'll just write how many things you need to check. Okay, let me put that boxes to analyze. Do you have the correct syntax or not? Okay, just cross check. Do you have this function syntax properly? Yes or no? Do you have this statement syntax properly? So any mistake that you see, let me know. So this many syntaxes you will verify. Of course, lexically everything is fine, right? Lexically everything is fine, right? When you group it, you have, there is no lexical error, right? No lexical error. How many tokens you got? How many tokens you got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 tokens we got. That means there is no error in lexical. So one kind of question is over. Now syntax, when you want to check, right, statement by statement you will check, right? You don't apply the brain. Remember that? Don't apply the semantic. Semantic is very dangerous. Syntax means just verify the what? The structure. Is that clear? Is these structures are valid? Just check. This is valid. Is this valid? Why valid? That you should understand. Many people are saying because this might be syntax error. No, this might match with when somebody writes type def statement. Let's say type def, I write int abc, then this statement is actually correct. There is no problem if I write within the main. That means this syntax is correct. This syntax is correct and no syntax error because this statement syntactically valid. Why valid? Because this ABC XYZ might have the meaning in semantic analysis. In syntax analysis it will ignore because the semantic analysis should verify that. Everybody? So semantic analysis will come into picture. Oh, this might be the declaration. I don't care. So the syntax analysis will ignore it. The semantic analysis, when it comes into picture, oh, this is should be some type, because ABC, if it is identifier, then there is no type is assigned. That means ABC is missing with the type. XYZ is not type. In the symbol table it is going to check. Oh, did I assign any type to this ABC and XYZ? No, that means there is a problem with the declaration. It gives an error. ABC is not declared, XYZ is not declared. There are two declarations issues happens here, right? And one more, the Y. Y also has no type. There's a third syntax error here. The Y is also not declared. There are three declaration errors comes. So that's why you will be having semantic error. You will be having which error? Semantic error. What error you will be having? So that this is error, the yellow marks, this one, let me put with other marks. So this ABC, XYZ and Y, here you will see semantic error. Of course, this line obviously semantic error. Even here also semantic issue is there. What issue is there? In both of them, semantic error. Declaration is missing. Undeclared variables. How many undeclared variables? 3 variables. ABC, XYZ and then Y. The syntax doesn't know that these are the variables or types. The semantic should come into picture and to verify. And 2 statements you will be having the semantic check errors. Total 3. Okay, got it? No syntax error. Okay, remember that there is no syntax error in this code. Okay, next one. Okay, some compilers, that's yeah, semantic error could be wide. That's good point. But some compilers will ignore that by default. Why? Why if it is lowercase letters, right? If it is uppercase, obviously there's a typing mistake. If it is wide is lowercase, there will be no error, right? Okay, that's fine. That take care of it. If that V is a uppercase letter, you will be seeing this is semantic error, because that should be written type. The type is checked by semantic error. If this V is the uppercase letter, right, then definitely it is a semantic error. So be careful that. I'm very sorry here. Next. Come on. What is the answer for the next one? We're very near to the end, right? There's 8 more questions left after this. Which of the following C expressions can be represented? These are not 3 address codes. These are what? What are they? C expression, just what you need to do. Indirectly what we are asking, which of the following are C expressions here? Every C expression, just understand logically. You don't need to understand how to write it. Of course you should learn. Every C expression has 3 address code. Just you need to check. Are they C expressions or not? Just tell me here. Can I write this in C? Can I write this in C? All are possible. Q of I, if it is having an address, right, you can put in star star P. C, why this is wrong? Star star P could be a value and Q could be a value and P. Is there any syntax error here? Value less than value could happen, anything, and that you are assigning 5 to X. All are C expressions, right? All are C expressions. A, B, C, D. Everybody you can convert into 3 address code. There will be no issue. If there is no compiler error, definitely you can convert into. These are the expressions in C, no doubt. Syntactically they are correct. Array X is not, I am talking about expression, right? Syntax you check, not the semantic. Only just check if they are valid C expressions, then you can convert into. Okay, semantically right or wrong, program will decide. Did I write the program? No, right? Just I have written one expression. Every statement I can make it valid by putting declarations and everything else. Okay, we are not writing whole C code. We are writing only one C expression. Assume remaining are proper. Like every variable is created, declared accordingly. Okay, we don't know what declaration, but by looking at it, you should understand. Oh, P is a double pointer and Q might be the integer and X might be the integer. So in that case, it works, right? Okay, assume there is no compiler error while understanding this question. This question is logically you need to check. Okay, by assuming there is no error, because there are valid expressions. You can make it valid if not valid, okay? Because C compiler allows them. So what would be the tokens in A of 3y, because somewhere I saw that we would have to convert it to the pointer format before counting, though no, that's wrong. But if you are implementing lexical analysis separately, Shivam, then what is your question? If you are implementing the lexical analysis separately, 1, 2, 3, 4, 5, 6, 7, that 7 tokens will be identified if the lexical analyzer alone, because it can't do anything. And just making the syntactically, later on syntax analysis comes, together this will be connected, and together this will be connected, and this one will be connected later on. But it's just 1, 2, 3, 4, 5, 6, 7. So 7 tokens has to be identified, and this will match with this one in syntax, not in lexical analysis. Okay, this one is here and another one is here. The syntax analysis will take care, but lexical analyzer will not know, and many things you will worry. Forget about this one. When you have the main, right? Why do you count these are two different? Because lexical analyzer will not match the balanced. So whether this comes or this comes, or what else you have? Anything. If this comes, no, it will count as a 2 tokens because it can't remember the syntax. Okay, only syntax analyzer should come whether it has the balanced one or not. Open, close, open, close. So syntax analyzer will verify that, but it should count as a 2 tokens only. By default, if you are looking for only lexical analyzer, okay. Okay. Okay, square should be how many tokens? If you want to count the tokens, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here 13 tokens are there. हाँ, वैनिश मिलेगा, क्यों नहीं मिलेगा? 2 घंटे ले सकते, 3 घंटे में, पता है आपको? 2 घंटे ब्रेक मिलेगा गेट के एग्जाम में. अगर गया ना, एग्जाम भी छोड़ना पड़ेगा यार. इनको ब्रेक चाहिए यार, क्या करें भाई. Okay, fine, good question. Keep it up. 3 घंटे भी ब्रेक ले सकते हैं हम, बट आपको गेट एग्जाम इंपॉर्टेंट है. एवरी मिनट इज इम्पोर्टेंट, राइट? You can't ignore even 1 minute. It's important. If you take 1 minute break, you should utilize 1 hour time. That is the target always. Next one. 23. Choose a correct statement for the above grammar. इनको पहले सिगरेट अलो करते क्या एग्जाम में? पहले ये पूछो उनसे. नॉट अलाउड. See, what is it? I don't think you should answer this way. C or D? What are you answering? I did not get it all. Oh ho ho. Okay, what were you doing? Are you constructing LR0? आप LR0 डायग्राम को कंस्ट्रक्ट किया क्या? CLR1 डायग्राम कंस्ट्रक्ट किया क्या? Right. That is the always important. First thing in compiler, check grammar ambiguity is there or not. Everyone. So it's a very straightforward, right? What you get here also same. Why are you looking for the SLR1, LLR1? There is a shortcut for this. Always give a priority ambiguity. If the grammar is ambiguous, right, then the answer is directly will go for the last option, right? This is ambiguous or not? DA. There is only one string, and that is also more than one parse tree. Very simple trick, very simple trick. Always focus when they are talking about LL1, LR0, SLR1, CLR1, LLR1, first focus should go to ambiguous. Is that can give an answer for us? Then check ambiguity. Yes, it is ambiguous. The answer is nothing. Not SLR1, not LLR1, right? You should put all the points at one place. As if that's the one issue. You are not recollecting all the important points, because when the question is there, you are only following what is given, but you are not looking for the connection. Yes, it's not only for you. Many people, even including me, sometimes I construct SLR1, then I will check for LLR1. Why? Because I forgot the connection, right? This can be answered when I know the ambiguity. So this question itself has an answer ambiguity, then directly we can go for the option D. So that connection is very important. Okay, it's always depends on how you focused when you are reading the question, right? The same question you read after every 2 months, you might not come up with the same explanation, because you need to have the focused. Those people who are having focused and you are able to connect, then those people can do check the ambiguity directly. Yeah. Yes, fine. Come to the revision, yeah. First do it and come to the revision. Okay. Next one. You can take very small break, like few seconds, but you can't take the minutes or hours in the exam. For relaxation, you just take 20 to 30 seconds, get relaxed or drink water, and just stand up and walk and come back in seconds. That makes you relax, right? That you should practice during mock test only. Yeah, next one. How many cells have multiple productions? That's very easy again. How many cells? Can you identify them? How many cells you have? There is no null production, right? The first set will have an answer. So those people who know the idea what is the table, very simple. From E you have A multiple productions. Why? Because AE, AT both are giving the same. So you can easily understand by looking at E productions. But B is alone, because B is only one production comes. But T another one. From T, when you look at B, there are two productions comes, B, F and F, because F also giving the B. Right? So those people who understand the grammar, they can directly come up with the answer. Okay, there are only two cells where you see multiple productions. One, cell 1, this is a cell, 1, this is another cell. So you will have two cells only. Even that can be, we don't need to consider the whole grammar, because null productions are not there. Then first and follow computation is not at all required. Just compute first. E on A, how many comes? E on B, how many comes? That's all. T on B, B you can see. So B both can come. That's all. Answer is over. For simple grammar, no need pen and paper. This can be analyzed with the just brain. Okay. So that's what the tricks in TOC and compiler. The most of the questions, if the question is very small and have the simple logic, just it can be done very quickly. But connection is very important. Okay, 25. Okay, at this time you need to use pen and paper, because sometimes the calculation may go wrong. So consider the positive very quickly, then do the calculations. If you're able to understand without that also, you can do it. But which one should be executed first is very important in the order. So please construct the tree. I'll do it here myself. The E, E1 both are same. Okay. Do you have this? Okay. So now we got one. E should be T and T should be f should be num. That num should be what? 2. And then t should give t and f, t ampersand f, and next t should be 2, like t to f, f to 2, and f to what? Directly 2. So we got the tree, and now just put where you want that rules. One rule, exact same place, right? Last only there, so you are so lucky you can connect last. If not last, be careful while putting this branches. Okay, last. Okay, now if you want to understand, right, as it is mentioned, nothing, no bottom of passing, nothing, right? As I told, just pull them down. Just you need to execute in this order. Pull them down. First, second, third, fourth, fifth, and what else? Sixth, 7, 8. These 8 rules you need to execute in the same order, but do exactly what they say. Okay, the first one, the f to 2 is saying that num dot value should be there in f. So here you are going to put equal to 2. And the second one, this is done. And the second one, t to f production, just send the value f to 2. That's going to be equal to 2. So this is also done. And the third one, that e to t, is just send the value. Oh, not sending. This is what I told. You need to look at t value plus 2. That's 2 plus 2 will be here 4. If you are keep on sending, right, you are wrong, because there is given plus 2. So you should execute that exactly. For t to f, f to num, just you are sending the value to the root, but you are not just sending, you are updating it to the by adding 2. So next one, now look at this one is also done now. F to 2, that's production you need to look at. That is 2 you need to send to the f. So I did it. Okay, this is also done. And t to f, just send the value up. Practice it. And now after this you need to come here. So don't look at here and there. Just come here. And what is it? F to 2. Just send the 2 to f, that we know. So done. And next, this one, t to t ampersand f, this one. So what are you doing? T multiply with f, t multiply with f, t multiply with 2 multiply with 2, 4. You get a 4 here, and you done that. Last one, that is e circle t, that is including dot. So that is e plus t. So you are just adding it, 4 plus 4, that you are doing here to the root, 8. So you want to compute the value at the root, so we'll get the answer is 8. So everybody got the answer? 8, 8. Somebody got the 4. So just cross check. 8. So if you got the tree, then that's done. Even they mention bottom up parser, do the same technique. Why? Because this is S attributed, then it will be L attributed too. Everybody, every S attributed is what? L attributed. Then either you do bottom up parsing or L attributed evaluation, answer will be same. Just always follow this technique. You will never do the mistake, because you are doing one by one in a sequence. But bottom up parsing makes a confusion. That's why we have this easy technique. Good. 8 you got right, then that's fine. So once you understand, but this plus 2 is the trick. Those people, they must write plus 2 is going to be very difficult. Okay, 25. Last 5 questions, guys. So this is what I want. Let's see the answers. Who will give me? You know me, right? Most of the times when I put 3 star, definitely somebody struck there and get the wrong answer. Okay, you need to correct. Once you get the answer, just try another best way. Great. Still you are studying, almost going to 12. I'm sorry today, actually it was supposed to be 7, but due to other work, I shifted to 9. I hope you did not face any difficulty, right? Any answer so far? What is the question? Minimum number of variables needed in 3AC or a SSA. You're able to answer it? Great. 4. That's what I'm expecting. 4, 3. Which one is the right? I think I do something? Okay, that's a good question, I guess. You have B, C, D. Next, anyhow, we don't need it. So, do you need any extra variable? That is a trick here. Do you need? The problem is, see, first what you do is this multiplication, right? First, you are going to do this. First, of course, it is also first. After doing this, you will go for plus minus in left to right order. That you are aware, right? Plus minus in left to right order. These two are independent. It's not that, you know, this first should be done first, because these two are independent positions. See, are you able to understand one thing? B star, C star, D. Maybe you will execute left to right. But you know that B star C or C star D, you evaluate, you will get the same answer, right? Because the multiplication is associative. When you are doing the code optimization, if the answer logic is not changing, then you can do whatever the principle you want to apply. Are you clear? Remember my point. These two are independent. And we know when the 2 star comes, they should be applied left to right. But the star is already associative. And anyhow, these 2 stars are not together. Their order doesn't matter in logic. Whether you execute B star C first or C star D doesn't matter. So there are two kinds of students. First, those people who think B star C first, they go wrong. Those people, they think C star D first, they are right. Are you getting my point? Why? What was the reason that B star C makes you fail? Because when you do B star C, you cannot assign to B, you cannot assign to C. That's a problem, because in future B is there and C is there. But when I do C star D first, I am free, D is the free. I can't assign even D because D is there, not at all used it. I can't reuse the variables. But here D is the free. Now D I can reuse here. Are you getting my point? When I do B star C, I was not able to use B, C, D, anybody existing one. But when I do C star D, oh, I am using the D. I don't want any extra variable. I have B, C, D, I can use them. That is the advantage. So here ordering the operations is one of the important the technique in the minimization. Everybody, if you want to minimize the variables, you should also look at which operation should be done first, because there are multiple operations which are independent. The ordering of the operations can change the result. Are you clear this point? Remember that line, ordering of the operations can change the number of variables. So now which one need to be done first, that can change your answer. So those people who are looking this first, you will get the wrong answer, because you can't use a B, C, D there. But if you use this, then the D will be free, because in the future D is not there. So now you are so lucky. Now here I can do something like this. Now C star D, right? This one I assign to D. Now I can do B star C. At this time you can see still, oh, can I do something else? B star C. Can I assign to B? Can I assign to C? There's one more issue now. Can I assign to B? Because B I am using here. Can I assign to C? I am using the C here. Still I can't use the B and C. Can everyone see that? Now B star C is required. But this is the way you should apply. Everybody clear? The ordering is very important. Right? In case, let me help you. Suppose, same expression, of course, just it is not there. Now you will succeed. I'm assuming why this technique is very important. Now see again, if I do B star C, in future still B is there, C is there. Now look at again. Look at this expression, just slightly modifying for those people who want the technique. See this one. Now look at, is that reordering technique will help or not? Now look at, if you do B star C first, oh, B is needed in future, C is needed in future, you can't override to B, you can't override to C. But if I do C star D first, I can keep in D because D is the free. Everybody clear this technique? Why is so important? Because you should always follow this technique. Doesn't matter whether you reduce the number of variables or not. 3 or 4, the final technique, even I don't remember it final answer, but this is always the technique. When the two operations can be done independently, you should look at two independently. So let me answer this first. So C star D in D, and then B star C at this point of time, you can put in C. So C is equal to B star C, because I was not able to do that in the previous example, so that you should know the technique at least. Now minus plus is there, then you have to do this, then C minus B, you can put either B or C, both are free. Let me put in C again, C, and then C plus D. So now C plus D, that I'll put C only. So C plus D, I'll put in C. So this is the answer for 3 variables. But previous example, when you have the C, you got 4 variables. The actual answer for the previous question was a 4, but when you don't have the C here, you will get a 3. Obviously, I could have asked this question, but while making, I forgot that C is there. Got my point? So this was the actual question where the people may do the mistake, but not the previous one. Previous one was a 4. Whether you do that or this, you got the answer luckily, but not all the time. For C is there, when C is there, definitely answer is what? Then for this question, the answer is definitely 4. But you should be very careful while reducing. Now the technique is, first you will do this only because D is the free. You will put into D. And then only you will try this. Now I am not able to put into D. Only you will try this. B, C, D. Oh, I am not able to put any one. So I'll put into some new variable T1. Then plus minus plus. Plus minus plus. Order is very important. So you will complete this first. C plus T1. Now you'll see that C is already done. So you can put in either C or T1. I'll take the C. Then C minus B. Both are free now. C minus B. C and B both are free. I'll put in C. Then C plus D. You can put into C. So total 4 variables for this question. Actual question, you need 4 variables. But this reordering is very important. This question you could have done mistake, but just because of the C, you were lucky. So this reordering, keep in mind, reordering is very important. Which one you take it, that will decide your answer. Okay, in the exam I have seen once, those people who have taken this, they got the wrong answer. Those people who have taken this mod, this, and they got the right answer. So always look at, is there any other operation that I can do first? Then do parallelly 2 ways. The one way you may get the best answer, then do it. Okay, so keep it as very important, and do with C and without C. And my intention was without C. Okay, 27. I think you don't need much time, right? Can you do on your own? Which of the following expression represents the given 3 address code? This is a 3 address code, but represented in quadruple notation, right? So this is a result. So first one is going to say something like x is equal to minus a, and second one is going to say y is equal to b multiply with x. And order is very important. Z is equal to c plus y, and c is equal to z. So this is a 3 address code. Now you need to go just from bottom to up. That c is equal to c plus 5 z, and z is c plus y, and y is b star x, and x is what? Just go from bottom to up. C plus, that is b star minus x is minus a. That's it. Which one is c plus b star minus a? Okay, that is c plus b star minus a. I think the second option, right? Yeah, you already did it. That's great. So let's complete it. Okay. Follow of S union first of S. Total number of terminals that you have in both. They may ask what is the cardinality. Sometimes they may ask something like this differently. Cardinality of follow of S union first of S. Might be easy question, but you should be very careful. Don't do this sum. Remember, very important, this question is different, and follow of S plus first of S, this question is different. So let's see both of them, then look at what is the right answer for this. Follow of S. What is the follow of S? Can you conclude quickly? Follow of S, dollar, close parenthesis, and B. Of course, this one says the same, so no need to write. What is the first of S? First of S is open parenthesis and AC. That's it, right? AC. Of course, this question looks like there is no difference, but in reality, these questions might change. But here, luckily, you are getting the same answer, looks like, but still, let me try that. Okay. What is the answer? Okay, anyhow, 3, these are different. That's why you got a 6 and 6. 3 plus 3. 3 plus 3, you got a 6. But is that always same? Okay, let me show one example to prove it. They are not always same. Okay, let me show that one thing. S derives, what is this color here? Okay, let me show that example too. S derives S or A. Can you compute the follow of S? You get definitely this S and this S, right? Dollar you will get, follow of S is first of S, you will also get A. So only two things will come. Just check later. First of S, you will get only A. Can you see that? The difference? Follow of S union first of S cardinality. The union you do first. That's you do the union, you will get dollar comma A union A. So that you will get the dollar comma A and the cardinality is 2. But when you do the follow of S cardinality plus the first of S cardinality, the mathematics principle, 2 plus 1, 3. Just I want to say, in the exam they may ask theoretically are they equivalent or not. You should say they are not equivalent. Okay, you already know this kind of concept in mathematics itself. A union B cardinality need not be equal to, need not be, that means need not be, right? It means need not be same. That's already mathematical concept, I guess you know it. So remember this point, even aptitude mathematics also, this point is very important. Okay, that's why I wanted to say there, but luckily we got a different, they are disjoint, both of them are. When they are disjoint, these two will match. In the exam also, when do they equal? You can say that the A intersection B is equal to pi. If A intersection B is equal to pi, then definitely you will be seeing that A union B cardinality is equal to cardinality of A plus cardinality of B. This kind of principles you could have studied already, right? And they are very important for the exam point of view. So that was happened in the previous example. Let's go to the second last question today. Can you answer it? Sorry. Just check quickly. LL1 or not. That is only the one which you can do very quickly. In probability you have seen, okay, great. I think we'll meet 2 to 3 times more, I guess, before the exam. 2 times, for one is for TOC, another for compiler revision, then last maybe before the exam once we'll meet. So 3 times more you may meet, and yeah, B might be the answer. Okay, is it ambiguous which string you are getting quickly? Are you getting any string? Are you getting any string which is common? Why are you saying B? Right, Shinchan. I'll write. If you want more sessions, yes, we may come up with the more sessions, but not planned it. We'll definitely come more times. We'll try. Because when I count, I see 2 to 3 times only. But we'll see many other sessions to guide. First check LL1, right? If the grammar is LL1, what is it? Always unambiguous. Don't check ambiguous. There's already undesirable problem, right? Takes much time. You don't know which string is going to have more than one pass, right? Never. Just look. Any ambiguity. If brain cannot answer it, don't use pen and paper. Pen and paper will take much time for ambiguity. Okay? There are only few things that you can do, that by just looking at, are you able to conclude ambiguity? No, don't do it. Oh, don't use a pen and paper, will take much time. So now check. Intersection first of AA. First of AA. Intersection first of B. Is it equal to empty? Is equal to pi? Oh, that means they can be LL1. There is no issue. The B never gives small a, right? You are lucky. Next, first of AA intersection first of B. Both are different. Yeah, no need to write it all. You know that. Here B is there, here C is there. All are in LL1. So LL1 is fine. But the question is MCQ. Then why do you look for other option? We don't look. Even other options are right. Then we don't care. We can challenge it. Right? If it is MCQ, we got one answer. Clearly, we know that it is LL1. Still, we'll check. Every LL1 is never be ambiguous. So we delete. And every LL1, we know that it's never be left recursive. We delete. Very straightforward, right? You will never get this two. Even it is MSQ, right? You can't choose this two at all. Because already you know LL1, you will never choose ambiguous, you will never choose left recursive. You know this point. Okay? So this one is already answering this two, never been chosen. You can't choose them. Okay, last one. Okay, very nice question, I think. Yeah, this is about control flow graph, because in code optimization, one question comes from the control flow graph. Okay, apart from code optimizations, the control flow graph is the first step before optimization. If you want to do any kind of analysis, then you must use the code, you must consider the control flow graph. You need to find the number of basic blocks. How many basic blocks? Again expected as numerical answer type. So let me do the control first, then I'll draw that later. Control enters, goes and goes here. So be careful. Here it's going two directions, either go down or go to the sixth one, and then sixth also will do some different way, something like this. And then after 4 will go to the fifth, and fifth again makes something different, that go to 2 means it will go to the 2 or it will go down. So finally it will exit. Are you able to write this control? On issue it is important. You should know that live variable analysis. How to find the live variables is very important topic. I'll bring to the revision session. Even PYQ also we missed it. You should know which variable is live at every point. That's a very important question. But not expected every year, right? The last year it was asked means it may not be asked again. Because whole compiler we will have the weightage around 4 to 5 marks only. How many? Okay, let's see. X is equal to A. Can you combine with Y is equal to B plus C? No, because somebody want only 2. Look at that edges. Somebody want only 2, so you can't club this 2. Because if you mix these 2, right, then somebody want to enter in the middle of the block. That's impossible. The basic block means the control only enters at the first and leaves at the last. So if you combine this control cannot enter in the middle of the block. That's why we are separating the 1. We are separating the 1 with the 2. This is the 1. And just keep like that. 2 we will write. 2 and 3, can I keep together? If you see it, oh, nobody coming in the middle, nobody leaving in the middle. So I can keep 3 together. And can I keep 4 together with this? No, why? Because if you look at here, from 3, the control leaves to somewhere else, not only 4. So this is an issue. Control may leave from 3 to 6, so the 4 you cannot combine, because when you combine 4, after 3, only 4 should be the next statement. But this is together. Now 4, we are going to start. 4 and 5, can I keep together? Because see, nobody enters in the middle of this. This means nobody wants 5. No, I write after 5 you can leave. But nobody leaving after 4, nobody entering after 4. That means 4 and 5 we can keep together, because it's always sequentially executed. And 6, oh, that may come even after 3, not only from 5. So after 5, you may go to even 2. That means 4 and 5, then 6 you can't combine. So 4 and 5 only will combine into the same basic block. Then 6 is only one which is alone. So keep it. Now this many basic blocks needed, and no need controls. If you understood the answer, the 4 is the basic blocks, and if you want to connect the controls, like you can see there, 1 to 2, and then 2 to 2, 3 is done, and 3 to 4, and 3 to 6 also there. You can keep that also here like this, and after 4, 5 you can go to the down, or you can go to the 2 also. So you can see everything properly like this. That's it. This is a control flow graph. Number of edges and nodes, when they ask here number of edges, they may not ask. When they ask, they will keep the nodes also. These 2 nodes, they will clearly mention whether they will be including or not. There one is a start node, another one is end node, stop. Either they will keep or they will ignore it. So when they keep it, this is extra edge comes, and here extra edge. But they are not controls. Remember that they are not controls. They are just by default edges. This blue markers optional basically. So in the exam, if they don't mention anything and they ask number of nodes, that's a different question. These are the basic blocks only. But if they ask number of nodes, then the question is 2 types. Nodes including start end, excluding start end. So be careful about that question. If they ask including start end, then add +2 to the basic blocks, you will get 6. If they ask exclude start and end, you may get a 4. Nodes excluding means the basic blocks only. Okay, so nodes, every basic block is a node, but this is not a basic block. This is a node, the start is a node, but not a basic block. These basic blocks are the nodes, but remember that every node is not a basic block. Okay, edges, controls, 2 different words. Controls means except these 2, everybody is a control, like 1, 2, and then 3, 4, 5. The 5 controls are there. Here you can see 5 controls means 5 jumps indirectly. They are called as jumps. You can keep this 4 nodes in different memory locations. You can just call the jump from here. Okay. Now 5 controls means 5 jumps are there. And then edges, when they ask, they may ask these special edges, then just add then the 7 edges here. So understand the question carefully. Are they saying anything excluding, including? If they don't say anything, they want just number of nodes and edges, just draw exactly what you see. If they ask only basic blocks, please don't include start and end, because they are not basic blocks. So number of basic blocks, just 4, but number of nodes, you should read the question. Nothing mentioned, then include start and end. If they mention don't include, then don't include. Okay, so read that question carefully. Oh, great, Shiva. Got the point? So 4 is the right answer. I think if you have any questions right now, you may ask. I'll be waiting for your doubts. And now the time is 12. If in question, if they don't say, if they ask number of nodes, then just basic blocks and the nodes, start and end, both you should include. Read the question. Nothing mentioned. They are asking about nodes. The question is different. Number of nodes, number of basic blocks, both questions are different. Nodes include everything. Basic blocks, but don't include the nodes there. Node never be basic block. A node, start and end nodes, they never be basic blocks. Okay, because there is no instruction there. Yeah, thank you everyone. And last these days, please utilize for your practice and revision. Is really important. Any question that you face right now really will help in the exam. Right? Learn everything smoothly and clearly. Yes, Nishu, that could be possible. Closure and go to, because you see, right, very few types of questions that comes from compiler. One is the closure and go to, one is first and follow, the other one is number of minimum number of variables. But expected questions only there in the exam most of the times. CFG will be given asking what type of CFG it is. You can predict the most of the questions in TOC. Yes, sir, compiler. Yeah. Good night everyone. See you guys. Bye. Take care.